All right, today we're going to look at day 2 of the imaginary numbers unit, 3.3, and today we're talking about how to add, subtract, and multiply complex numbers. All right, so to start off, we're just going to refresh our memory on a few things. First off, the square root of 100, remember, is just going to be equal to positive 10, and then the square root of negative 81, that is going to be equal to, remember we have to pull that I out for the negative, and the square root of 81 is 9, so that is 9i. Now part A, obviously that's a real number, because that's a real 10, but part B is an example of an imaginary number, because that is an imaginary 9i. Now, a complex number is written in standard form as a number a plus bi, where a and b are both real numbers, and the number a is the real part, number bi is the imaginary part. So complex is bringing together a real number with an imaginary number. Okay? Now, this part at the bottom, we don't need to go over. It's not going to be tested or quizzed over, so we're skipping it for Algebra 2. Okay. Next, we're going to talk about how to add or subtract complex numbers. Okay, so when you add or subtract complex numbers, all you have to do is add the real parts together and add the imaginary parts together. So for letter A, the real parts are 2 and 5, and the imaginary parts are 3i and negative 6i. So you add the real with the real, so that's 2 plus 5, so that's 7, and the imaginary with the imaginary. So 3i plus negative 6i, that becomes negative 3i. Same thing is true for subtraction, but we do have to be a little bit more careful because we are subtracting. We're not just subtracting the 5, we're also subtracting the negative 6. So this is the same thing as 3 minus I minus 5 plus 6i, because when I subtract a negative, it's like adding a positive. In other words, I'm distributing this negative to both the 5 and the negative 6i. So now I'm ready to do my combining like terms here. 3 minus 5 is negative 2. Negative I plus 6i is positive 5i. So that is my final answer there, negative 2 plus 5i. So when we multiply, what we really need to be careful of and really need to remember is that anytime I multiply an I times an I, that is the same thing as I squared. And I squared means negative 1. Okay, so anytime I end up with an I squared, and that only happens when I'm multiplying, not when I'm adding or subtracting, I get an I squared, and I can change that into a negative 1. So 2i times 3i, I multiply the 2 times the 3 to get a 6, and then I multiply the i's together to get an I squared. Now remember, I squared, that's the same thing as negative 1, so that's 6 times negative 1. So that simplifies to negative 6. Part B here, 4i times negative 6 plus I. Remember, that I'm just going to distribute now the 4i with the negative 6 and with the I. So that's 4i times negative 6, that's negative 24i. And 4i times I is going to be 4i squared. Now remember, I squared is the same thing as negative 1. And that means I have negative 24i minus 4. Now I do want to make sure that we are very careful here. The real part always, always, always has to come first. The imaginary part always goes second. So we're just going to flip the order here. Negative 4 minus 24i. So just be careful with that. For C, we are going to do some double distribution. So the 9, we're going to multiply with the negative 4 and with the 7i. The negative 2i, we're going to multiply with the negative 4 and with the positive 7i. So we must have to multiply both things in the first parentheses with both things in the second parentheses. So that's 9 times negative 4, so that's negative 36. 9 times 7i, that is 63i. Negative 2i times negative 4 is positive 8i. And then negative 2i times 7i is negative 14i squared. So we need to simplify. So negative 36 comes down, 63i and 8i. That becomes a 71i. And then I have this minus 14 times I squared, which is the same thing as negative 14 times negative 1. So I can turn that into a positive 14. And so then I can combine these like terms, negative 36 and positive 14. They're both real numbers. So I can add those together. Add real with real. So that becomes negative 22 plus 71i. And then the last example here, 5 minus 2i squared. Rewriting that, that's the same thing as 5 minus 2i times 5 minus 2i. So we multiply first together, then the outer two terms, then the inner two terms, then the last terms. So 5 times 5 is 25. 5 times negative 2i is negative 10i. Negative 2i times 5 is negative 10i. And then negative 2i times negative 2i is positive 4i squared. So we end up with, simplifying this, negative 20i. 4 times I squared, that's going to be the same thing as 4 times negative 1, so negative 4. 25 minus 4 is 21, minus 20i. And that's my final answer. There is one more example that wasn't in your notes, so I do want you to add to your notes, and that is, what if we have the same numbers? We'll do 6 plus 3i multiplied with the same numbers, but with a different sign between them, 6 minus 3i. Okay? What this is called is a complex conjugate, and we're going to spend a lot of times with complex conjugates in the next lesson, but I just want to introduce you to them now because they do appear a little bit in your homework. So we're still going to multiply these the same way. 6 times 6, 6 times negative 3i, 3i times 6, and then 3i times negative 3i. So that's 36, negative 18i, then we got a positive 18i, and then we have a negative 9i squared. So 18i and positive 18i, negative 18i, positive 18i, those are going to cancel each other out. So we're left with 36. And I squared, remember, is negative 1, so that's negative 9 times negative 1, so that's plus 9. So our answer is 45. And that is our final answer. It's a real 45, nothing imaginary about that. All right, so just wanted to see that in action. And then if you have any questions, please shoot me an email or a Canvas message, and I'll get back to you as soon as I can. Have a great day.